17.1 is radical expressions and graphs, and in this course we will not be looking at the graphing part, we're just going to look at the algebraic part of radical expressions. Okay, example 1 on page 1198 is asking us to find all the square roots. So the square root of 100 means what number times itself gives me 100? Well, 10. But also, negative 10 times negative 10 gives me 100, because a negative times a negative is a positive. So for B, the square root of 25 is going to be negative 5 and positive 5, because negative 5 times negative 5 is 25, and 5 times 5 is 25. On C, the square root of 36 is negative 6 and 6. And then for D, when you have a fraction, you can rewrite it as the square root of 25 over the square root of 36, and take the square root of each, so that's 5 over 6, and it can also be the negative 5 over 6. So for every perfect square, you have two square roots, the positive and the negative. Alright, since every perfect square has two square roots, the positive and the negative, we're going to distinguish between whether we are discussing the positive or the principal square root of a, and the negative this way. So if it just has the square root of a, then we're specifically looking for the positive one, which is also sometimes called the principal square root. If it has a negative in front, then we're wanting the negative square root of a. So this just shows the square root of a times the square root of a is the square root of a squared, which is a, and the negative square root of a times the negative square root of a is also equal to a, and the square root of 0 is 0. For example 2, it says find each square root. So a, the square root of 16, we're looking for the principal square root or the positive square root. So what number times itself equals 16? 4. B, negative square root of 169 is going to be negative 13, because 13 times 13 is 169. C, the negative square root of 225, so we know it's going to be negative, and what number times itself is 225? 15. D, we're looking for a number that you can multiply by itself to equal 729, which is 27. And for the bigger numbers, you just kind of have to try different things. Like if you know 25 times 25 is a pretty common one, it's 625, so you know it's going to be bigger than 25. And so you just try a few numbers higher than that. So you have calculators, so you could easily multiply 26 times 26, 27 times 27, find one that works. And then for E, this is the square root of 36 over the square root of 25, which is going to be 6 over 5. And then the square root of 0.49. So I know that 7 times 7 gives me 49. So to get the decimal of 0.49, it's going to be 0.7. Because if I multiply 0.7 times 0.7, 7 times 7 is 49, and then there's two numbers behind the decimal, so that would give me my 0.49. In the previous two examples, we were finding the square roots of numbers. On example 3, we'll be finding the square of each radical expression. So if I have the square root of 41, if I square that, then it means I'm multiplying the square root of 41 times the square root of 41. The square root of 41 squared, the square root and the squared are just canceling each other out, and it's just going to be equal to 41. So anytime you square a square root, you're just undoing the square root, and you're going to get what's left inside it. So when I square the square root of 39, that's just going to give me 39, and then I'm squaring the negative also, and negative times negative is positive. And then this one, when I square that, then it just cancels the square root, and I'm just left with 2x squared plus 3. So this is going to be a really, really important concept for this whole chapter 17. So make sure that even though these examples look really easy, make sure you really understand the concept of them, because we'll be applying them to a lot of different problems. Before the next example, on this slide we'll be reviewing some vocabulary. So we have 3 cases that we're going to be looking at. If A is a positive real number that is a perfect square, so if A is 1, 4, 9, 16, 25, 36, 49, if it's a perfect square and it's positive, then the square root of A is rational. It's a rational number. Our second case, if A is a positive real number that is not a perfect square, so it can be 2, 3, 5, 6, 7, 8, 13, any number that's not a perfect square but still positive, A is an irrational number. Pi is an irrational number. Square root of 2 is an irrational number. Square root of 10 is an irrational number. So any square root that cannot be simplified to a whole number is irrational. If A is a negative real number, then the square root of A is not real. So if you have a negative under the square root, then it's not real. Example 4, tell whether each square root is rational, irrational, or not a real number. So A, the square root of 9. Well, the square root of 9 is 3, which is rational. Remember, a rational number is anything you can write as a fraction. So if it comes out to a whole number 3, I can write it as 3 over 1. B, the square root of 7 is it's not a perfect square, so it's not going to reduce to a whole number. So that one's going to be irrational. C, 4 and 9 are both perfect squares, so that would be 2/3, and anything that can be written in fraction form is rational. So again, back to our definition, if the number is a perfect square, then it's rational. 72 is not a perfect square, so that's irrational. And all it means for it to be irrational is, like, if you were to put it into the calculator, you would get a long decimal, you would have to round it, as the decimal will keep going forever without repeating. And then E, the square root of negative 43, well, you can't have a negative under the radical, so that's not a real number. And the reason you can't have a negative under the radical is because square roots means if you have a number times itself, gives you that. So 3 times 3 is 9 for A. 2/3 times 2/3 is 4/9. The others are decimals. But if I multiply a number times itself, I'll never get a negative, because a positive times positive is positive, and negative times negative is positive. So there's not a number I can multiply by itself and get a negative. So that's why if you take the square root of a negative number, it will always be not a real number. In example 5, we're just going to complete a list of all my perfect cubes and perfect fourths. So 1 cubed means 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3, which is 9 times 3 is 27. And for the fourths, the same thing, you multiply it 4 times. So we're just going to fill in this chart, and then that way you have it to refer back to as you're working on your homework. Now, when you take your test, my suggestion for this chapter, because you're going to be using your cubes and your fourths a lot, is to recreate this chart on your blue book before you even start answering number 1. Just open your blue book, make your list. You have a calculator that you can use, so multiply them out and make your list. And that way, throughout your test, you can go back and look at it, and you're not having to try to go back and think of what they are, recalculate them every time. So we'll go ahead and continue the next one. 4 times 4 times 4 is 64. And so I'm just going to go ahead and complete the rest of the chart. Okay, so in example 6, you can go back to your chart and look at that to answer these. So the first one is the cubed root of 27. So cubed root means what number multiplied by itself 3 times. So a number times itself again. So the cubed root of 27 is going to be 3, because 3 times 3 is 9, and 9 times 3 is 27. The cube root of 64 is 4, because 4 times 4 times 4 is 64. And the cube root of negative 125 is negative 5, because negative 5 times negative 5 is positive 25. And 25 times negative 5 is negative 125. So you can't have a negative under a square root or any other even index, but under a cubed root you can, because a negative times a negative times a negative is a negative. On example 4, it says find each root. So a is the fourth root of 81. So again, we can go back to our chart that we made, and we find that 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. The fourth root of negative 81. If I multiply a negative times a negative, that's going to give me a positive, times another negative gives me a negative, times another negative gives me a positive. So any even number of negatives is always going to give me a positive answer. Therefore, I will never get a negative under the fourth root. So b is not a real number. Okay, c, notice the negative on c is outside of the root, so I'm going to take the fourth root of 81, which is 3, and then I want the negative of that, which is negative 3. So then for d, we have the fifth root. Now we didn't do a table for fifth root, so we might have to do a little bit of calculating. So I know that the fourth root of 81 is 3, so if I do 3 times 3 times 3 times 3 times 3, this part's 81 times another 3 is 243. So the fifth root of 243 is 3, because if I multiply by itself 5 times, that's what I get. And then the fifth root of negative 243, well, a negative times itself an odd number of times gives me a negative. So this one's just going to be negative 3. Okay, so on page 1204, we have these blue boxes that said, for example, in this one, if you have the square root of a squared, for any real number a, the square root of a squared is equal to the absolute value of a. And then here's some examples of that. The square root of 7 squared is the absolute value of 7, which is 7. b, if you have negative 7 squared, it's going to be the absolute value of negative 7, which is 7. So when it's a number, it doesn't really make that big of a difference. You're going to get the positive number. But if you have a variable, you have to leave your answer in absolute value form. And that's the part that most people will forget, is that when there's a variable, like on these two, you have to leave your final answer with the absolute values around them. So this works for in general also. If it's an even positive integer, so you're taking a square root, a fourth root, a sixth root, an eighth root, then you're going to have the absolute value signs. If it's an odd, so the cubed root, fifth root, seventh root, then it's without the absolute values. So just remember, you use the absolute values when it's even. It's not necessary when it's odd. Okay, so in example 9, find each square root that's a real number. So the square root of 15 squared is going to be the absolute value of 15, which is just 15. Another way to do it is to say 15 squared is 225, and the square root of 225 is 15. So the square root of negative 12 squared is going to be the absolute value of negative 12, which is 12. And again, you could also work it out kind of a longer way by saying negative 12 squared is positive 144, and the square root of 144 is 12. Okay, so now when we have variables, the square root of r squared is going to be the absolute value of r, and the square root of negative r squared is going to be the absolute value of r as well. Okay, and the reason that this last one is the same is because if I take the absolute value of negative r, that's the same thing as the absolute value of r. So putting it with numbers, for example, the absolute value of negative 3 is 3, and the absolute value of 3 is also 3. So it doesn't matter whether you have the positive or the negative inside the absolute value, they're going to be the same thing. In example 10, simplify the following radicals. So the fourth root of negative 5 to the fourth, that is an even index. So we're going to take the absolute value of negative 5, which is 5. Then on B, it's an odd, so when it's odd, I don't need the absolute value sign, so it's just going to be negative 7. On C, it's even, so I do need the absolute values, and notice I have a negative in front, so negative absolute value of negative 3, so that's going to be negative, the absolute value of 3 is 3. Okay, on the first three examples were in the form nth root of a to the n, so the index and the exponent match. They were exactly the same number. On D, I'm taking the fourth root of m to the 8th, so I need to know how many m to the fourths there are. So this is the same thing as negative fourth root of m to the fourth and another m to the fourth. So I have 2 m to the fourths. So it's going to be negative m squared. So we got squared because I have 1, 2 of them coming out. And then if I'm squaring a number, it's going to be positive. So this absolute value of m squared is just m squared. And then I have this negative at front. So my final answer is just negative m squared. So for E, I need to know how many x cubes there are in x to the 24. So basically it's going to be 24 divided by 3, which is x to the 8th. And since it's odd, I don't need the absolute value symbol. And then on F, how many x to the 6th can I make in x to the 18th? So 18 divided by 6 is 3. So it's going to be the absolute value of y cubed. And this one I do have to keep the absolute value symbol because a cubed can come out to be negative. In example 11, we will be using a calculator to approximate each radical to 3 decimal places. So when you're approximating to 3 decimal places, you need to look at the 4th decimal place to see how you're going to round it. So the first one is the square root of 17, and that comes out to 4.1231. So since my 4th place is a 1, then it's going to round to 4.123. Okay, for B, negative square root of 362. It's going to be negative 19.026 and then 2, so negative 19.026. C, the cubed root comes out to 21.1657, so the 7 is going to round that up to a 6. And the last one is 9.9 .0892, so it'll stay .089.